and welcome to our first episode of Agile TD Mondays. My guest today is Gil Zilberfeld. In a minute, he is going to talk about creating a unit testing strategy. But beforehand, I would like to invite you again to the Agile Testing Days USA. The registration is open and tickets are on sale. We have over 50 top agile and testing experts who share their knowledge about lean software testing, mob programming, for example, API testing, agile development, automation, and many more. And I invite you to check out the full agenda on the Agile Testing Days US homepage. The conference will be from the 19th to the 21st of June, and it's going to be in Boston. And if you register now, you can save up to $300. Now to Gil Zilberfeld and his talk.
Thank you, Sabina. Glad to be here today. I hope you will enjoy this session as well. It's called Creating Unit Testing Strategy. And usually we don't think about unit testing something that requires a strategy, but we'll probably see that it does. A few words about myself. I'm Gil. I live in Israel. I've been part of the Agile Testing Days community for 5 or 6 years now, and I'm very happy to be part of this community. Apart from my site that has all kinds of Agile things, I also have a site called Everyday Unit Testing, which is about the book that I'm writing, and it includes a lot of stuff about everyday unit testing. I also live on Twitter, so you can find me there. Let's jump into the topic itself. So unit testing, we seem to think about it as a methodology, right? So there's a class or a method we want to test this part of the code. We also find that people think about unit testing as an equivalent to a tool like JUnit or NUnit. And when I ask them, well, what kind of strategy for unit testing do you have? They look at me funny. So let's see why it does need a strategy. I won't go into details this time about the Agile testing quadrants. I can spend a whole day just talking about this. But this is one of the first thing I show people who start out in unit testing. And I show them Brian Mack's quadrants. And this is to show that unit testing is just part of the entire quality effort that we're putting into the product. It has its own place. There are obviously other types of tests that we're going to write, automate, run manually, explore, but it is part of a whole package. This is why we need to think about it this way when we move forward, when we're doing some planning. Unit testing is not just a methodology, it's a whole set of skills, and I've written like just a bunch of them here. Planning, how we're going to test these things, writing the tests themselves to have more effective tests, maintainable tests. Designing tests, how are we going to design the code maybe and the tests in order for them to run and how to run them effectively. Prioritizing, we don't have the entire set of time in the world to run and write tests, unfortunately. So we need to prioritize which are more important than others, which we should write first. The whole testing mentality is something that sometimes developers don't get, and they need to be better at. And instead of how do I make this work, thinking about how do I break this, or what will happen if I do something else. Reporting is another thing. How do we see the results of our tests in a test report or in continuous integrations? And refactoring, both code for tests and the production code itself. These are all set of skills, and there are probably others that people need to get better at when they're writing tests. So as we can see, there's already some things that we already have or we might want to acquire in the test, in the team, in order to improve our efforts. So it does require some kind of strategy. So when we're starting out to plan a new feature, we need to think about how we're going to do this. What parts of the feature we're going to test, which are more important, which are more crucial, where are the risks, what kind of tests, what kind of unit tests we're going to write, and for the whole quality effort, what kind of end-to-end tests, maybe integration and component tests, how are we going to divide the effort? And the idea is to give us the most confidence through feedback of that we can sleep at night better. And also, what can we not test? Because, like I said, we don't have the entire all the time in the world. So we need to think about all these things. And what I do with people is usually go through a process of usually a lot of questions, which we'll see here. It requires 10 steps that start way before we write the first line of code or test and finish way after that. So let's go through these steps. The things I'm going to start with are prerequisites, things that I assume that you already have in your team. If you don't, we need to have another discussion. The first is source control. Obviously, most people don't work without source control now, but I get surprised from time to time. Continuous integration like Jenkins or Microsoft TFS or any, there are a lot of both commercial and open source vendors out there. And that allows us to build and run tests automatically, sometimes more than that. Branching methodology is something that people might not think they have, but for examples, uh, building and merging things on the trunk is a methodology. This is how we write tests, add features to the code. But you might have feature branches, you might have other variations, and it is important to know this thing because it will affect how you're going to run tests, how merges are going to be applied, and how you're going to affect these tests. Finally, a lot of teams don't have formal training in unit testing. And if they do, it's only about the tools and how to use them, which is nice, but usually requires a bit more. So I'm assuming that when we're going to this process, there's a bit more experience in writing effective tests. At the beginning, when we're starting to plan, there's also a way of an opportunity to discuss how we're going to attack this. It might be not just a regular way we do it. So it could be like write tests after the code is done, like we used to, but it's also an opportunity to try test first approaches like TDD, test-driven development, or BDD, behavior-driven development. Somebody else will write the tests. Um, Tools are usually something that is a closed set, but there are always popping new stuff that is interesting to see. One of the cool things that I'm looking at right now is Serenity as a BDD framework. And it might be an opportunity to say, on this feature, we're going to try these kind of tools. It is also important to look at the skill set that you have in the team and look at who's more um, um, it was better to write these kind of features and tests and maybe pair them with someone we want to increase these skills with. So a bit of planning. The first thing we do when we're writing the features is try to understand the problem. Usually as developers, we just jump in and we just build anything that we can write, code everything that we can think of that solves the problem. But usually that's the worst approach because at the beginning we don't know much about the problem. So talking with the product and the testers and the developers, everyone together, slicing the stories, defining edge cases, defining what is important, what is risky, mapping out like with mind maps on a board all different test cases, we can actually understand what is the problem we're trying to solve. And this is, like I said before, writing a bit of code, and it is much more helpful than just jumping into the code. One of the things we need to we need to take into account is what kind of code we have. So usually we have what we call legacy code. Legacy code is is a very fancy word for code that we wrote once and we don't touch it because it works. And unfortunately, there's a lot of code out there like that. And if we want to start covering it with tests, there's probably going to be an effort of moving stuff around to make it more testable. So we need to discuss the risks. If the code that we're changing and adding tests is critical code, which is usually the case, because otherwise, why would we test it? If bugs are recurring in this piece of code, so our feature is going to be in a place where we already fixed a bug and it created another bug in there, and bugs are recurring in this place. These are the places we actually want to cover with tests, and there might be some effort in making it more testable. So there is going to be some kind of preparatory refactoring before we actually, or as we are writing the code itself and the test themselves. So that means we need to take into account this kind of effort and risks into our plan. What we usually do then is discuss a solution. Usually developers do that by themselves, but this is really kind of a miss. But because usually a solution needs to take into account not just what we're going to build, all the things that we already discussed, but we need to talk about dependencies, like if our system calls third-party systems or web services that might or may not or may be available when we run them automatically. What will we need to mock? What kind of dependencies we're going to mock? What kind of tests we're going to run? And like, for example, we need a database. Is mocking the way to go, or running an in-memory database a way to go? So even in terms of testability, we need to think about what we're going to do. And this is a good place to remind everyone that even the designing the solution should take into account testers as well. This is not a developer activity. At the end, testers, hopefully not at the end, the testers will need to test the system somehow. So if the developers don't put seams in for the testers to put in probes and see what's going on, it will be hard to test. And usually when it's hard to test, we just don't test, which is not a good way to go. So this is for kind of the things that we do in the codes in terms of design to make it more testable. Um, there are patterns which I'm not going to go in details, but you can look them up. Ports and adapters is a way to write code in a way we can inject dependencies in. We need to expose seams or to expose state if we want them to be available. Add logs so that so when we're testing and there's a problem, we can figure out what the problem is. Shared state is something that we might want to avoid. We might not be able to, but singletons and stuff like that might want to consider alternatives. And finally, solid principles, which usually define as good code principles, usually align together with high level of testability. We then start to think about, up until now we haven't written a line of code, I know. We now start to think about what kind of tests we actually need, because now we understand the problem, we have at least somehow, at least one option, if not more, of a solution design for the problem. We have an idea of what the boundaries of the system is. So we can start thinking about what kind of tests we're going to write. We can define what is a unit in this feature, because it could be like a piece of code, it could be a component, it could be a set of components. We also need to think about how we're going to organize the test, because somehow, sometimes the test organization, as where they are geographically on the disk, may impact how we're going to run them in the continuous integration system. So for example, if your tests are organized based on functionality, so you're thinking, well, we already have like 10 tests for this kind of feature, then we add the next one in the 11th in the same way. However, assuming that you have these 10 tests already, and one of them is very slow, and you're adding unit tests, all of them will run together unless you do some kind of effort to separate them. So you'll get the feedback slowly, even if you can get it early on. So test organization really impacts the way we get feedback on our quality. So obviously, what can we run quickly and separate those into different levels, both geographically on where the tests are located. Also, in terms of CI cycles. In continuous integration, we want to run the quickest test first in order to get the quickest possible feedback. And then we can allow the longer test to run. Yeah, I've added a slide about actually writing the tests in the code. So yeah, because we actually need to do those as well. And then we come to the last couple of steps that are people forget to do sometimes, which is kind of a miss. The first thing is to do a review of what we actually did. So obviously a code review, but people sometimes forget to do a test review as well. So code review is a must, obviously, and test review is part of it. When we do a test review, we review the test we've written, see if the names are clear, see if the code there is clear. And test code is just like regular code. We need to remove duplications from it. It's really a plague in tests that we copy one test to another and just modify it a bit. So we just create when we're moving into the next test. So we're kind of creating this application by ourselves all the time. We want the test to be as clear for us or somebody else in 6 months when we already forgetting what we've written, to make sure that when something fails, it will be A, for the right reason, and B, that when somebody picks it up, he will have all the breadcrumbs to see where the problem is and fix it quickly. If there is some kind of documentation that you need to do, you need to do that as well. It really falls down into what kind of definition of done you have. Remember, the definition of done is something that it's not the acceptance criteria of the feature. Definition of done is a quality checklist of what you're going to do before you actually finish things up, so we know what done is. So obviously testing and code reviews, if some kind of documentation, if you're having some kind of procedures of deployment of done, do that as well. So it's very important to make sure that what you've really written is really come up to the done level of the quality you expect from what you produce. And the final step is knowledge sharing. You've already done the effort, you wrote the tests, you've learned a lot about how to test this piece of code. You know how it's designed, you know what the pitfalls are, you know what the risks are, assuming that you didn't have all the time of the world, because that's the assumption. You've tested just parts of it. You might want to share this knowledge as well with other people, maybe other groups, because they might want to learn how you tested this kind of feature because they have something similar that they're going to develop. All this learning should not go to waste. And you should have like either reviews or what we call community of practice, like teams inside the organization, sharing knowledge of how to write and improve the tests and according to the code that you write. And as you can see, there's an actual process for that. This is what I see as starting point. Because every company, every organization, every team has a different kind of way to work around it. So it is like a starting point where you understand your code, what kind of needs you need to fulfill, what risks you need to answer, and you can modify this to whatever process that you feel will fit your benefit. The only thing I want you to do is to start thinking about unit testing, not just something that you add on at the end of the task, but as a whole process. Because when you do think about all these steps, break it down to all these kind of small steps, and do the thinking, which doesn't require a lot, but it does require some kind of collaboration. You raise the quality level, just like I said, before even starting to write a single line of code. Thank you for showing up. If you have any questions, you can ask them here, or you can hit me later on Twitter, and be sure to check my sites. Thank you.
The thing I want to do is tell you who's my guest next week, and I have two guests. It will be Sam Lang and Karen Greaves, and they will provide you with some tips to apply agile practices and principles in distributed teams. I hope you enjoyed the talk. Thank you very much for joining me, Gil.
Thank you.
And I see you next Monday when Sam and Karen are my guests. So see you then. Bye.